located in northern Sweden. It's actually not there. It's by the the Y there. So really close to Umeå, where my department is. And as I said, it's 6,000 or 7,000 hectares. Within this area that you see here is like what we call the research station area. And here we have conducted forest research in 100 years. So these different places, or especially Flakaviden, or there's another place here called Rosenedal and so on. But they have had forestry research there in 100 years. And also here in this stream, we monitored hydrology since 1980s, and then also on all these plots they also monitor hydrology now, but not so for 12 years ongoing. So measuring every minute, every day. So right now in this location, it's a spring flood, which is a really important part of the hydrology there. Half of the water comes as snow in this landscape, and then now it melts in the spring. So everything comes like whoop, in a big peak of flow. So there's a lot of studies going on hydrology and so on, and we understand the system quite a lot. And then related to this also, we have this silviculture studies here, and also ICOS tower is located here. So it's integrated carbon observatory system. So it's an eddy-covariance tower of 150 meters. So it's both measuring the carbon that the trees take in, but also the carbon that the whole landscape is taking in. So looking at the carbon fluxes, but also environmental fluxes, so the water cycle and so on. So basically, this is a closed system in a way, because we know how much water is coming out, and we know how much water is coming in with the precipitation, and we also see how much is coming with this eddy-covariance. In my project, which is related to many of the other projects, I've added a forest and soil inventory.
My also.
Oh, really?
Yes. My current thesis work is on soil warming and its effect on pine roots.
All right.
You know the pine roots? So it seems to be related with you.
Yeah, really good. So within this area, there's 550 permanent plots. But I've dug pits down to 65 centimeters on 443 of them. I've taken soil samples both of the organic layer.
Yes. Which method you use?
This is not the bulk density estimate, but it's I dig with a shovel.
Shovel.
So
Yes.
you dig quite a big hole like this. Down to
Is it
65
core? Is the core? You know the soil coring method?
It's till soil, so it's unsorted sediment, so a lot of rocks. So bulk density is very different.
Okay.
But here actually here's a big river, like one of the biggest in Sweden, and here is where the old river went. So it's sediment soils here, so sorted sediments here, and that affects quite a lot how it looks like. So it's really flat here, but here the topography is, for you it's probably very gentle, but you see here you almost don't see any mountains or anything, but yeah, that's how it looks anyway. Adjacent to this soil inventory, we also inventory the trees on these plots, which are 10 meter radius. So we inventoried them first 2015, so all the species and the height, so adjacent to a LiDAR scanning. And then 2019 we did the re-inventory. So we have 2 years of LiDAR scannings and forest inventory, so we can estimate the forest growth in the whole landscape using LiDAR data. So with that LiDAR data, I've also created a DM report, so I can predict the soil moisture within this landscape. And now I'm trying to relate that to both the carbon stock in the soil.
How can I? Sorry for interrupt.
The soil moisture.
How you predict the soil?
The soil moisture, yeah.
How you predict?
How I predict?
Yes,
Yeah.
using any software or?
Yeah. So it's not. The maps are built in different ways, but we have a machine-learned soil moisture map, which is based on DM, and the most important variable is something called the depth water index, depth to water index, but also other variables as for the whole country one, it's climate is in there, but it's mostly topographic wetness indices, and they work quite well. But it's mostly because in Sweden we have these unsorted till soils or sediment soils, and the water follows topography really well. So and we don't have these steep hills and so on. So predicting where mires are and riparian zones is quite easy in Sweden. And what I do is I try to relate both forest growth to these soil moisture maps, because we get nutrients with the water that kind of flows down and it creates conditions that are better and worse for the trees. But I also try to relate that to my soil inventory and try to predict the carbon stock within the soil. So it's a big.
I'm interested on carbon stock.
Yeah, cool. And you are welcome. It was really cool. I actually got my last soil samples analyzed now, so now I have a complete data set of these. It's over 2,000 samples.
So you usually analyze the soil sample and estimate the carbon. And you don't use the GIS. You don't use GIS.
I will use GIS to predict that carbon soil. But I mean, I have actual points and then I build a model for that. So I can use it to use digital soil mapping, for example. It will be one project, but also a carbon estimate over the whole landscape. So you can take a mean value of all the points and something like that. So you can do a lot of things with it. So it's not going to be only my project, so it's going to continue like that. And we have also analyzed, this is our lab's poster. So I've analyzed both carbon and nitrogen on my both the organic layer and the mineral soil samples at different depths.